Newton's second law question part 1. This question is related to an experiment that we previously talked about. The first part of the question is, use the results in table 1.2.1 to plot a graph of acceleration against force. In part B, calculate the value of 1 over mass for each entry in the first column of table 1.2.2 and plot acceleration against 1 over mass for this set of results. We are not going to draw part A and B because we already did them in another video. The video's name is called Investigating the Relationship Between Force F, Mass M, and Acceleration A. So try to do them on your own and check how you did based on that video. Okay, now let's look at part C. Calculate the gradient of the best fit line for each graph. This is the graph which represents the relation between the acceleration and force. To calculate the gradient or slope, we need to draw a triangle under the blue line. Draw any triangle as long as the length and base are clear. Okay, this is our triangle. Here we have the length. The length is 0.6. It is from here to here. Each square has a scale of 0.2. Now for the base. Here each square has a scale of 0.1. So the base is equal to 0.3. Always remember to write the units. The length is 0.6 meters per second squared according to the y-axis, and the base is Newton according to the x-axis. Now for the gradient. It is equal to length divided by base. We already know the length and the base. The length is 0.6 meters per second squared divided by 0.3 Newton. The answer is 2 meters per second squared per Newton, or we can write it like this, which is 2 meters per second squared, and Newton is to the power -1. This is the measure of the gradient or slope. So we simply drew a triangle and we defined the length and the base. Then we divided them to get the gradient. Notice that the straight line passes through the origin. So any graph like this goes back to the rule, which is y equals cx, where y is any number on the y-axis and x is any number on the x-axis, and c is the constant number, which is the gradient or slope. So c is y over x. And that is how we found the gradient or the slope.